Good morning, everybody. I'm glad everybody made it. My name is Brenda. I'm the CEO and one of the co-founders of Tellor. Tellor is a decentralized oracle. There's lots of oracles out there, but our story is that we actually joined the crypto revolution trying to do decentralized derivatives in 2017, 2018, and we realized very quickly that a lot of the infrastructure did not even exist, and we were already too deep into the system. So we went ahead and we tried and developed something for our own purposes at the time, and we came up with the very first MVP for Tellor. And that was in 2018. The only thing available was Oracleize, which may be still surviving as provable. And obviously, we needed and wanted something that was actually decentralized and that we can hopefully, outlive us and be able to be used, with a liveness guarantee that a centralized oracle cannot guarantee. And at that point in time, there were really no oracles around, honestly. And we all set out, not just us, but I think just individually, like a bunch of people started working on this problem and trying to solve it. And we succeeded in actually finally providing people that are joining the industry now a whole array of oracles, from centralized to decentralized. There are all sorts of flavors, all sorts of specialization, non-specialization. There's so many options out there popping up every day that it's even hard to keep up. And last year, I actually went back and I looked at all of the hacks that happened in 2023. And one of the things that stuck out the most was that ultimately, the majority of the hacks on oracles, I mean, we've done such a great job that the actual oracle protocols are not getting really hacked. The way that oracle hacks generally happen, it's by people actually manipulating the asset or the definition of the asset, or how the asset that we're pushing on chain. So the actual problem has shifted from the protocols and trying to solve how to trustlessly push data on chain to the actual quality of the data. And that's basically the biggest realization that we've made up to now, at least in Tellor, is that we have some pretty strong protocols out there already. But in terms of data definitions, and I know I have a few of my peers here that have developed their own oracles, we often have users that come to us and tell us, I want the price of some random altcoin that they launched yesterday, right? And we're like, what? Like, how many sources are there? Is there enough liquidity? Is this even safe? Are you seriously trying to secure that much value with this thing, And we have to go back and really educate our users into that is not probably the way that you should be implementing an oracle, or in any way or shape, because no matter what oracle you choose, if you give them a shit definition, you're gonna get bad data, no matter what. Trash in, trash out. That has not changed in crypto or in general. So one of the other realizations that we've made through these engagements is that we have to look at security as an effort, as an effort of different layers of things that you have to do to actually secure your protocol. One, obviously, your data quality or your data definition has to be at a better state than it has been before. Two, you have plenty of oracle options out there. Choose something that aligns with your values and that actually fits what you're building. Three, implement them correctly. If you're gonna choose an oracle, make sure that when you implement it the proper way, or the way that you minimize any of their weaknesses within your system. And then always assume that the oracle is going to fail, or the data definition is going to fail. How are you gonna handle that? Even Maker has a freezing mechanism. If they can afford to do that, you can probably afford to do that. You're not that big yet. And then the last thing that it's become more of a recent problem is actual attacks on the chain. Levana protocol exists in Osmosis chain, and the way that they were attacked, does anybody remember Black Thursday here? Yeah, okay, a few of you, right? So that according to me, was something that just happened. It was a market thing, and there was a bunch of congestion on Ethereum, and the actual Oracle couldn't update properly. And that ended up causing a bunch of liquidations at Maker, actually. And luckily for them, they were able to put a backstop and freeze their system and stop the bleeding. But either way, this is something that happened just because of market conditions. In Levana protocol, they were attacked by basically recreating this mishap on Ethereum, but on that chain because it was way cheaper to attack the chain. So these hackers were basically congesting the chain and not allowing Oracle updates until they set their system up to take advantage of the price that was coming in and make profit out of that. So they knew what was going to be the update, and they paired that with transactions to take advantage of that. And because they were causing the congestion, they knew exactly when the congestion was going to stop and the Oracle updates were going to happen. And I think that as we move on to seeing all of these new app chains developing, the number one reasons that we develop app chains is because we want more control over our protocols, and a lot of the times we want to have better control of the gas costs that we have. And when you are decreasing the gas costs on your chain, you're also decreasing the cost of attack. And so this attack is already out of the cat's out of the hat. It's going to probably continue to happen. And so that this is something you have to start thinking as you develop your own protocols if you decide to go that route. And then the last thing is everything that's on chain, or the code that's on chain, the way that I see it is the base rules of the game. And if anybody comes, a hacker comes over and they're like, okay, these are the base rules of the game, but I found a way to basically cheat the system. That is a hack, right? And so I think there is, aside from the code, there's a social contract that we sort of enter into when we opt in to use any protocol. It's like, that's the way that it's supposed to work. And so when it fails to work, or when somebody takes advantage of a weakness, I think it's completely acceptable for you to have your social layer determine, your community determine, well, we're not gonna do this, so we're just gonna fork you. And you can spend as much resources as you want trying to hack the system or trying to play or game the system, but ultimately, we're going to fork you out. And I think just a credible threat can go a very long way to keep those type of attacks away. So those have been like the main takeaways that we've had, or that we've learned through the years. And with that, we have set ourselves to really try and design a system where we can actually support an environment that keeps expanding every day. And the good thing about this, though, is that now, as opposed to 2018, we have way better bridges. We have an ever-expanding ecosystems that are working really hard to be interoperable. And even Bitcoin is on this game, which forever I thought that they would never join because, they were always very very, very strict or very pure in the technology. So it was, I'm very surprised that now, like within the last year, they've had so many people join their ecosystem, and it's really expanding. And then last but not least, CK proofs are actually, they still need work, but they're way faster than they were in 2018. They're way cheaper than they were in 2018. Actually, they're probably way cheaper than they were last year. And every day they keep getting better and better. And so we want to take advantage of all of these of this evolution and these improvements, and set ourselves up to use all of this and focus really on what we see as currently the problem, and develop a system that allows us for better and more robust data to be achieved through a decentralized way. So we're focusing, basically, our V2 of Tellor is going to be its standalone L1. The only thing that can happen there is coming to consensus on data. And we are focusing a big portion of that on data quality. And for that, basically, we want to be able to collect as much data on chain before we come up with an official value to provide to our users. That allows us to improve our security, and that is our main focus is if we see that there's plenty of options in terms of oracles, and I see the problem now is the data quality, how do we improve it? Obviously, interoperability is at the top of our list because currently for Tellor to go to any other chain, we have to deploy our contracts. For anybody to become a data reporter, they have to stake on that chain, so we depend on a bridge to be able to bridge our token TRB for them to be able to stake, to initiate disputes, to pay the data reporters. So we want to take that away and set ourselves up so that as the ecosystem expands and demand expands, then our security should as well. And we should not be operating under the assumption that somebody else is going to come up with a bridge for us. Obviously, decentralization for Tellor is at a core of our values, and so we're always I know I have a lot of Oracle peers here. You guys know that we're optimistic. We're a little bit slower, but we definitely want to always emphasize decentralization. And with the increasing data quality, we want to continue to support experimentation in crypto, right? All of these new app chains keep popping up, mainly because they're experimenting. We're still trying to find market fit. We're still trying to find other ways to use the technology to improve traditional systems. And so for us, what that means is that we want to create a system that allows for as many reporters as we possibly can get, because that helps us create robust data on chain. And these reporters need to be able to decline on providing data or data for queries or questions that are too subjective or very high risk, because every time that they provide data, they run the risk of getting disputed and losing that money if they get it wrong. So they have to have the choice to provide data or not provide data. But with that choice, that means that we can have a bunch of data reporters and be able to support things very robustly and be able to support things that are very niche or long tail assets that maybe only some people are willing to take the risk to report, or even things that can only be really verified by a handful of people or less than 2/3 of the aggregate weight of the chain. Obviously, we cannot do the same. And just this slide, the main thing about this that I want to point out is that we're actually going to be using our own system to bridge our token to our chain. That's the only token that's going to go to our chain. There is a 12-hour delay before people can actually claim their tokens on our chain, and it's purposefully very slow. And the same way going back out of the bridge, it's very slow because our model is we're not a bridge, we're just using this for our purposes. And when they deposits and withdrawals are also capped to make it to attempt to make that honeypot as inaccessible as possible for hackers. It just takes a longer time. It allows us to react if anything was to happen. But we are using Tellor for our own purposes. And then for validators, if we want to be interoperable, we have to, unfortunately, at this moment in time, cap our validators, because otherwise we won't be Lightbridge friendly. And we're using the Cosmos SDK for our chain, so that was a trade-off that we had to make, and we're fine with doing that because we're reaching consensus with as many reporters as we can within our own chain, and it's just a matter of using the attestations of the state of the chain to push the data to some other chain, and we can use that. You can use CK proofs, and I'm sure as more bridges, IBC, as more bridges begin to be enabled and be developed, then people can have way more options. They don't have to use just what we provide. But this is a trade-off that we did have to make, and we are fine with doing it for now. And as technology evolves, we hope to be able to increase that. I talked a little bit about robust and optimistic data, or how we want to be able to provide basically a playground for people to get data that a lot of people are happy and willing to provide on chain, and also be able to ask random one-off questions or questions that only a few people are willing to provide on chain. And for that, we call robust data things that are supported by 2/3 of the weight the staked weight of the validators, and anything under that is just considered optimistic. And can be disputed. If the data is considered robust, then basically you're saying that the chain has been compromised. So in general, robust data can be used a lot faster than you can optimistic. And you're making a big claim if you think that robust data is actually it's incorrect. The last thing, obviously, our bridge. I already covered this, but the main thing for interoperability for us was really removing that dependency of having to call the chain. It's like, hey, or what bridge is up and running that we can trust to tell people if they want to go and stake their tokens, their TRB tokens, and become a reporter that they can actually trust. Because we wouldn't want to tell people, hey, go use this, and then they get hacked. So it's really great not to have to depend on that, and we're just bridging data, and that is basically the only thing that we want to bridge. That is what we're doing. That is our bread and butter. That's what we know how to do best. And lastly, this ecosystem that we're creating, or this new chain that we're creating, this V2, because V1 will live forever, the main purpose of this is we still want to allow people to experiment, because it's an ever-expanding ecosystem. People are doing random things, and at this point, I don't think that I know exactly what they're doing or what's going to be the end game. So we want to make sure that we provide a sandbox for them to play. And then obviously we want to stay as interoperable as possible. In the past, we have made different iterations of Tellor that have been non-EVM. So we've done Cadena, we've done Polkadot, Algorand. And those are really big builds, and they're very expensive. But now, whenever we want to go to another chain, the build is so much smaller, because it's just the data bridge that we're creating. So it's just a much smaller contract. And then obviously, we are trying to collect as much data as possible on our chain before we come up with an official value. And that's basically to create more robust data and to try and provide more quality assurance in terms of that data. And also expand, be able to expand farther than just pricing models. Like one of the things that we have been working in the background, and one of my, I guess, little side projects has been trying to recreate a decentralized CPI, and I think creating a structure that allows us to collect more information and create more robust systems for data will eventually allow us to create not just things that are, if we're trying to create an alternative financial system, we need a lot more than just prices on chain. And I think eventually we're going to have to, instead of just being data providers as oracles, we're going to have to do much better, and we're going to have to be data creators and quality assurance and education always to our users. But with that, I hope you guys got some value out of this, of what we've learned. I know everybody has a different emphasis in terms of oracles, of what we focus and specialize, but this is sort of our learnings through the years and what we're trying to experiment as we see the ecosystem expand. And I'm out of time, but I'm happy to answer any questions. So.